Okay, get this. NASA's testing a new spacecraft design, and it's based on an airplane from the 1960s
Hmm.
that didn't even have wings.
Oh, wow, really?
You heard that right?
Interesting.
Wingless. I know,
Yeah.
it seems kind of impossible, right?
It does. Planes need wings to fly. I mean, how?
Yeah, exactly. That's what we're going to unpack today.
Okay.
We're looking at a NASA press release about this new atmospheric probe they're working on.
Okay.
It's based on this wild concept called a lifting body, which,
Ooh.
believe it or not, was first explored back in the 1960s.
Wow. That's fascinating how NASA looks back at these old ideas
Yeah.
and finds ways to kind of revive them.
Exactly.
The TOB is a perfect example.
Okay, so before we get into this new probe,
Yeah.
let's break down the basics. What exactly is a lifting body?
Okay.
And how on earth does a plane fly without wings?
I know, right?
Yeah.
Think about a paper airplane, right?
Mm.
It glides,
Right?
but it doesn't have that complex wing structure of a jumbo jet.
Yeah.
It's the shape of the paper airplane that creates lift.
Hmm.
A lifting body works in a similar way.
So it's not just about having wings, but the overall shape of the craft.
Precisely. It's all about the aerodynamics.
Okay.
The shape of a lifting body is carefully designed
Yeah.
so that as air flows over it, it creates areas of high pressure underneath and lower pressure above.
Okay.
And that pressure difference is what generates lift and allows the craft to stay up in the air.
So it's like the air itself is pushing the craft upwards.
Exactly. And what's really cool is that NASA actually experimented with lifting bodies back in the 1960s as part of their research into spacecraft that could maneuver in the atmosphere.
Oh, wow.
These early lifting body aircraft,
Yeah.
they were basically gliders
Hmm.
piloted by these incredibly brave test pilots.
Can you imagine being at the controls of one of those things?
Right.
Oh, man, talk about a white knuckle ride.
Now,
I can just
Yeah.
picture those test pilots pushing the limits, trying to figure out how these unusual shapes behave in the air.
it was a pretty daring time in aerospace history.
Yeah.
They were gathering crucial data on how lifting bodies perform during flight.
Mm-hmm.
And those early tests laid the groundwork for what we're seeing today with this new probe.
It's amazing to think that an idea from over 50 years ago
I know.
is being used to potentially change how we explore other planets.
Yeah.
Okay, so let's fast forward to today.
Okay.
Tell me about this recent test flight that NASA conducted with the
Right.
new lifting body probe.
Right.
Where did it take place?
This latest test took place at Rogers Dry Lake.
Okay.
It's this vast, flat expanse near NASA's Armstrong Flight Research Center in California.
Gotcha.
Now, they didn't just launch this thing from a runway.
Okay.
They used a quad-rotor drone
Oh, wow.
to lift the probe up to a height of about 560 feet
Okay.
and then released it.
Okay, I'm on the edge of my seat.
Yeah.
How did it go? Did it actually fly?
It did, and not just fly, it flew stably, proving that the concept actually works.
Okay.
The team was ecstatic.
Yeah.
This was actually their second attempt, though.
Oh. What happened with the first one?
Well, during the first test flight back in August,
Mm-hmm.
they ran into a couple of hiccups.
Okay.
The release mechanism didn't function quite as planned,
Oh.
and the airflow from the drone itself
Yeah.
was interfering with the probe's stability.
So a bit of a bumpy start.
You could say that.
Yeah.
But, that's the beauty of engineering and scientific advancement.
Right.
You learn from your mistakes, you adapt,
Mm.
and you try again.
It's all part of the process, right?
Yeah,
Failure is just a stepping stone to success.
absolutely.
Yeah.
The team took everything they learned from that first flight,
Okay.
made some key adjustments to the probe's design
Hmm.
and the release mechanism,
Yeah.
and went back to the drawing board.
Okay.
And clearly, those refinements paid off
Mm.
because the October test flight was a resounding success.
Yeah, it really is a testament to that iterative design process.
Absolutely. You tweak, you refine,
Yeah.
and ultimately you end up with a design that works.
Exactly.
Speaking of design, what are the next steps for this wingless wonder?
Well, the team isn't resting on their laurels. They're already planning. The next phase of testing, which will involve flying the probe at even higher altitudes.
Makes sense. The higher they go, the more data they can gather.
Exactly. And they're not just going higher.
Okay.
They're also planning to equip future prototypes
Yeah.
with a whole suite of scientific instruments. Think sensors that can measure atmospheric pressure, temperature, wind speed,
Okay.
even analyze the chemical composition of the atmosphere.
Wow. So it's like sending a mini mobile science lab
Yeah.
to another planet.
That's a great way to put it.
Yeah.
And remember, all of this is leading towards the ultimate goal.
Okay.
A spacefaring probe that could detach from a satellite orbiting another planet.
And then descend through the atmosphere, collecting all sorts of valuable data along the way.
Okay, that's where it gets really interesting.
Right.
We've talked about how this tech works.
Yeah.
Why is this such a big deal? What kind of data are they hoping to collect, and why is it so important?
Well, for starters, studying a planet's atmosphere can give us a window into its history, its climate,
okay.
and even its potential for harboring life. I mean, think about it. The atmosphere is a planet's fingerprint,
Yeah.
a unique signature that tells a story about its evolution.
So by analyzing the atmosphere, we can get clues about what a planet is made of,
Exactly, man.
what its weather is like, and maybe even if there are signs of life.
Exactly. And the beauty of this type of probe is its potential versatility.
Okay.
I mean, they can tailor the design and instrumentation to suit different mission objectives. Imagine studying the incredibly dense and hot atmosphere of Venus one day,
Yeah.
and then the thin, frigid atmosphere of Mars the next.
It's like having a universal key to unlock the secrets of planetary atmospheres across our solar system and beyond.
Precisely. And what's even more exciting
Yeah.
is that this type of probe could potentially be more cost-effective
Okay.
and a more efficient way to study other planets compared to some of the larger, more complex missions.
So not only could it lead to groundbreaking scientific discoveries,
Right.
but it could also do it more efficiently and affordably.
Yeah.
That's pretty amazing.
It's a win-win, really.
Yeah.
And it just highlights the importance of thinking outside the box when it comes to space exploration.
Right.
Sometimes the most innovative solutions are the ones that reimagine existing technologies in new and creative ways.
You know, all this talk about other planets makes me wonder.
Yeah.
Could this lifting body technology be applied here on Earth as well?
That's a great question, and the answer is absolutely.
Oh, wow.
In fact, lifting body designs are already being used in a variety of applications here on Earth. For example, some drones and unmanned aerial vehicles
Okay.
utilize lifting body shapes for increased stability and maneuverability.
So it's not just a space thing.
Not at all.
Yeah.
Lifting bodies have some unique advantages that make them suitable
Yeah.
for various applications,
Okay.
both in the air and even potentially underwater.
Underwater. Seriously, I never would have thought of that.
It might sound surprising, but there's been some fascinating research into using lifting body shapes for underwater vehicles.
Wow.
Remember, the principles of fluid dynamics apply whether you're moving through air or water.
Right.
So a well-designed lifting body shape
Yeah.
could potentially be very efficient for underwater exploration.
Wow, that opens up a whole new world of possibilities.
It really does. It's a perfect example of how scientific advancements in one field
Yeah.
can often have ripple effects across other industries and disciplines. What starts as a solution for one problem can lead to innovations in completely unexpected areas.
I love that. It shows how interconnected everything really is.
Exactly. And it's a reminder that we should always be open
Yeah.
to exploring new ideas and looking for connections between seemingly disparate fields.
Right.
You never know what amazing discoveries are waiting to be made when we step outside our usual boxes.
Okay, so we've covered a lot of ground today.
We have.
From 1960s gliders to futuristic space probes.
Yeah.
We've explored how the concept of a lifting body has evolved and the incredible potential it holds for the future of exploration, both here on Earth and beyond.
It's pretty amazing.
It is.
Yeah.
But I'm curious, for all those listening, what's the one key takeaway you want them to remember about NASA's wingless wonder?
I'd say this.
Okay.
Sometimes the most groundbreaking innovations come from looking back at the past and finding new ways to apply seemingly outdated ideas.
Yeah.
We shouldn't be afraid to dust off those forgotten concepts
Right.
and see if they can help us solve today's challenges. Who knows?
Yeah.
Maybe one of our listeners will be inspired to come up with the next big breakthrough.
That's a great point. After all, the sky's the limit when it comes to human ingenuity.
Or maybe even beyond the sky.
Yeah.
It's incredible to think that an idea from over 50 years ago could help us unlock some of the biggest mysteries of our universe.
It really is. It just goes to show that sometimes the best solutions are hiding in plain sight.
Right.
We just need to be open to looking at things in new ways.
Exactly.
But let's bring this back down to Earth for a second.
Okay.
We've talked about the scientific potential.
Yeah.
But what about its practicality? Is this something that we can actually scale up for larger missions?
That's a great question. And honestly, it's a bit early to say for sure. This technology is still in its experimental stages,
Right.
but one of the most promising aspects is its potential for scalability
Okay.
because it relies on the shape rather than complex wing structures.
Yeah.
It could theoretically be adapted for a range of sizes.
So you're saying we could see larger, more robust probes built using this concept?
Exactly. And that opens up even more possibilities for future missions. Imagine a lifting body probe large enough to carry a rover, or even a sample return capsule.
Wow.
We could be talking about missions that go beyond simply observing a planet's atmosphere
Yeah.
and actually interact with its surface.
Now that's a game changer. It sounds like this is the start of a whole new era of planetary exploration.
I think you're right. And what's even more exciting
Yeah.
is that the knowledge and technologies developed for these space-based lifting bodies could have valuable applications back here on Earth as well.
We talked a bit about drones and underwater vehicles,
Right.
but are there any other potential uses we haven't even considered?
I think that's one of the most intriguing aspects of scientific discovery.
Yeah.
We often find solutions that have unforeseen benefits. For example, the research into lifting body aerodynamics could lead to improvements in the design of aircraft, making them more fuel efficient,
Okay.
or allowing them to operate in more extreme environments.
It's amazing to think that a project focused on exploring other planets
I know.
could end up having a real impact on our lives back here on Earth.
Yeah.
It's a great reminder that investing in science and exploration is investing in our future.
Couldn't agree more.
Yeah.
It's all about pushing the boundaries of knowledge and understanding. And who knows, maybe the next big breakthrough will be inspired by something we've discussed today.
Well, I think we've given our listeners a lot to think about.
We have.
We've gone from the basic principles of aerodynamics to the potential for this tech to revolutionize how we explore our universe.
Yeah, it's been a pretty fascinating deep dive.
It really has. It's a reminder that the spirit of exploration is alive and well.
Definitely.
Whether we're looking back to the past for inspiration or gazing out at the stars with wonder, there's always something new to discover.
Absolutely.
So to everyone listening, keep that sense of curiosity alive, keep asking questions, and keep exploring.
Right.
You never know what incredible discoveries are waiting just around the corner. Exactly. Until next time, thanks for joining us on The Deep Dive.